Question 1. In the context of fire-damaged HVAC systems, Mr. Alvarez discovers that several flexible duct sections are coated with heavy protein-based soot after a kitchen fire. Considering the delicate nature of flexible ducts, what should Mr. Alvarez do to restore these ducts effectively without causing further damage? A. Use high-pressure air blasting to remove all soot rapidly. B. Employ gentle chemical cleaning with compatible agents and soft brushes. C. Replace all flexible ducts immediately without attempting cleaning. D. Wipe with a dry cloth and run the system to circulate air. Answer. Correct answer. B. Explanation. Protein-based soot is extremely sticky and can penetrate porous duct surfaces. High-pressure air could embed soot further, potentially tearing delicate flexible ducts. Immediate replacement might be wasteful if restoration is possible. Dry wiping alone is ineffective because residue remains embedded. Continuing odor issues. Using compatible chemical cleaning with soft brushes preserves duct integrity, removes soot, and prepares the system for odor mitigation. This aligns with best practices in fire restoration and HVAC material compatibility, preventing corrosion and ensuring long-term system performance. Question 2. Given the circumstances, Thompson is inspecting an electric blower motor in a fire-damaged air handling unit. She notes soot accumulation inside the windings and slight heat discoloration. What is the most appropriate next step to ensure safe and reliable operation? A. Immediately apply lubricant and run the motor. B. Disassemble, clean the windings, inspect insulation, and test continuity. C. Replace the motor without inspection, assuming soot caused irreversible damage. D. Use a vacuum cleaner on the exterior only, then restart. Answer. Correct answer. D. Explanation. Simply vacuuming the exterior is insufficient for internal soot and thermal damage, potentially leaving residue that can cause short circuits. Lubricating without inspection risks further damage. Full disassembly and cleaning is the most thorough approach, including testing insulation and continuity. Replacing without assessment could be unnecessary and costly. Professional fire restoration standards dictate careful internal proper cleaning and testing of electrical components after exposure to heat and corrosive soot to ensure operational safety and compliance with electrical codes. Question 3. As demonstrated by recent fire damage cases, Lee needs to mitigate smoke odor in a residential HVAC system after small living room fire. The odor persists despite duct cleaning. Which technique would most effectively neutralize the residual odors throughout the system? A. Thermal fogging or ozone treatment of the ductwork. B. Increasing airflow through standard filter replacement. C. Using scented air fresheners in ducts. D. Painting the ducts internally with a sealant. Answer. Correct answer. A. Explanation. Residual smoke odor can remain embedded in duct surfaces, insulation, and AC components. Standard filters or increased airflow cannot neutralize volatile compounds causing the odor. Air fresheners only mask odors temporarily. Internal painting does not remove odor molecules and may damage system components. Thermal fogging or ozone treatment penetrates porous surfaces and chemically neutralizes smoke particles, consistent with advanced odor mitigation protocols in fire restoration. Proper application ensures safety and restores indoor air quality without further material damage. Question 4. Considering the evidence, Mr. Patel is evaluating whether a fire-damaged HVAC condenser coil made of aluminum should be restored or replaced. The coil has light smoke residue but no visible structural deformation. What should guide his decision? A. Always replace aluminum coils after smoke exposure. B. Perform specialized chemical cleaning while inspecting for corrosion and integrity. C. Use aggressive mechanical scraping to remove residue. D. Ignore minor residue since aluminum is fire resistant. Answer. Correct answer. C. Explanation. Aluminum coils are susceptible to damage if aggressive mechanical methods are used. Total replacement is unnecessary for light smoke residue and adds cost. Ignoring residue risks odor and long-term corrosion. Proper restoration requires chemical cleaning with agents compatible with aluminum to remove soot while preserving fin integrity. Mechanical scraping could damage fins, reducing heat transfer efficiency. Decision should weigh material condition, residue type, and restoration techniques to maintain system performance and comply with fire restoration standards. Question 5. From a practical standpoint, is Rivera finds wet smoke residue in the ductwork after a small fire in a restaurant kitchen. What restoration approach is most consistent with best practices for this type of residue? A. Encapsulation and low moisture cleaning techniques. B. High heat drying without cleaning. C. Simple surface wiping in running HVAC. D. Full duct replacement regardless of residue type. Answer. Correct answer. C. Explanation. Wet smoke residues are sticky, odorous, and chemically reactive. Surface wiping alone does not remove the residue completely, leaving odor and corrosion potential. High heat drying may fix residue and worsen damage. Encapsulation is effective for dry residues but may trap wet residues. Full replacement is only justified if cleaning fails. Proper restoration involves identifying residue type, chemical-compatible cleaning agents, and low-pressure cleaning techniques to preserve duct integrity and ensure compliance with fire restoration guidelines while mitigating health and odor risks. Question 6. While examining a fire-damaged HVACR system, Mr. Johnson notices that the thermostat wiring insulation is partially melted. Which of the following actions aligns best with safety and restoration standards? A. Replace only the damaged section with matching insulation and reconnect. B. Inspect the entire wiring circuit, replace compromised wiring, and verify system operation. C. Continue using the wiring if the thermostat still responds. D. Cover melted insulation with electrical tape and operate normally. Answer. Correct answer. B. Explanation. Partial damage to thermostat wiring indicates exposure to heat that may compromise the entire circuit's integrity. Simply patching with tape or replacing section rest shorts or fire hazards. Continuing operation without inspection violates safety and restoration standards. The correct approach involves inspecting the full circuit, replacing any compromised wiring with co-compliant materials, and testing for function. This method ensures safe operation, prevents electrical failures, and aligns with OSHA and fire restoration best practices for HVACR systems exposed to heat and smoke. Question 7. Upon closer examination, Ahmed is evaluating whether the blower assembly in a fire-damaged rooftop unit can be reused. The metal housing is intact but heavily coated with dry smoke residue. What is the recommended restoration procedure? A. Chemical cleaning with non-corrosive agents. Disassemble motor if necessary and inspect bearings. B. High-pressure sandblasting to remove all residues. C. Apply light oil over the residue and reinstall. D. Ignore residue since dry smoke is non-corrosive. Answer. Correct answer. D. Explanation. Dry smoke residues are abrasive and can damage surfaces over time if not removed. Ignoring residues risks odor and system inefficiency. High-pressure methods like sandblasting can distort or damage the blower housing and fins. Simply applying oil traps residue and exacerbates contamination. The correct method involves careful chemical cleaning using agents compatible with metals, disassembly if necessary, and bearings and motor components to restore function while maintaining system integrity. This ensures performance, odor control, and compliance with restoration safety standards. Question 8. Through the lens of fire chemistry, Mr. Simmons must determine whether the soot in a unit is protein-based or carbohydrate-based to select the proper cleaning method. Which is the most reliable approach? A. Smell the residue to identify type. B. Visual inspection and chemical testing with appropriate reagents. C. Assume all soot is the same and use standard alkaline cleaners. D. Wipe with a damp cloth to see if residue smears. Answer. Correct answer. C. Explanation. Identifying soot type is crucial because protein-based soot reacts differently to cleaning agents than carbohydrate-based or dry soot. Smell and simple wiping are unreliable, and using a generic approach may damage sensitive materials or leave residues. Chemical testing ensures accurate classification, guiding proper cleaning agents and methods. Following these procedures prevents further corrosion, odor retention, material incompatibility. Advanced restoration protocols emphasize residue identification before treatment to ensure safety, efficiency, and compliance with fire restoration best practices. Question 9. In terms of refrigerant safety, Carter must recover refrigerant from a fire-damaged system where the compressor shows heat discoloration. What is the most appropriate procedure to minimize risk? A. Open the system and vent refrigerant outdoors immediately. B. Use HEPA-certified recovery equipment and follow Section 608 protocols. C. Heat the refrigerant to accelerate recovery. D. Bypass the compressor and release refrigerant into the unit. Answer. Correct answer. A. Explanation. Venting refrigerants is illegal, environmentally harmful, and unsafe. Bypassing the compressor or heating the system introduces risk of explosions or chemical exposure. Proper refrigerant management mandates using certified recovery equipment following EPA Section 608 standards to safely capture and store refrigerant. This minimizes environmental impact, prevents regulatory violations, and safety for restoration personnel. Heat-discolored compressors may contain compromised seals or pressure components, so careful handling during recovery is essential to prevent leaks or injuries. Question 10. Taking into account post-fire system testing, Istanuan has completed duct cleaning, odor mitigation, and motor restoration. What final step ensures the system is both safe and operational before returning to service? A. Perform a full system startup, monitor airflow, electrical load, and verify temperature outputs. B. Assume cleaning success and resume normal operation. C. Replace all filters and run on low speed only. D. Schedule the system for a future inspection without testing. Answer. Correct answer. B. Explanation. Assuming success without functional testing risks latent safety hazards, inadequate airflow, or electrical issues remaining undetected. Simply changing filters or scheduling future inspections does not verify operational integrity. Best practices require a full system startup, measuring airflow, checking electrical loads, and verifying temperature outputs to confirm performance and safety. This ensures that all actions were effective, complies with fire restoration protocols, and safeguards the occupants. Testing validates repairs, confirms odor elimination, and prevents costly failures post-restoration. Question 11. In a context of post-fire restoration, Mr. Daniels is assessing a rooftop unit with visible corrosion on copper tubing after exposure to acidic smoke residues. Which action aligns with best practices to restore system function without causing further damage? A. Replace all copper tubing immediately regardless of extent of damage. B. Clean the tubing with chemical agents compatible with copper, inspect for leaks and pressure test. C. Apply a protective coating over corrosion without cleaning. D. Use high-pressure water blasting to remove all residue. Answer. Correct answer. B. Explanation. Acidic smoke residues can corrode copper surfaces and lead to leaks. Immediate replacement is costly and unnecessary if damage is minor. Protective coatings without cleaning trap corrosive residues, exacerbating deterioration. High-pressure water can deform or stress tubing. Proper restoration requires chemical cleaning agents that are compatible with copper, followed by visual inspection and pressure testing to ensure integrity. This method preserves tubing, ensures safe operation, and complies with HVACR fire restoration and material compatibility guidelines. Question 12. From a practical standpoint, Grant is restoring a fire-damaged air handler where wet smoke residue has penetrated insulation around the motor housing. What should be her priority action? A. Replace all insulation and leave motor untouched. B. Remove contaminated insulation, thoroughly clean motor, and replace insulation with fire-safe material. C. Run the motor at low speed to dry the insulation. D. Apply anti-corrosion spray over the insulation without removing it. Answer. Correct answer. D. Explanation. Wet smoke penetrates insulation, risking odor retention and corrosion on motor components. Simply running the motor to dry insulation may exacerbate residue adherence and heat damage. Anti-corrosion spray alone cannot remove residue and may be unsafe if applied over contaminated insulation. Best practice involves removing contaminated insulation, cleaning the motor thoroughly to eliminate soot and moisture, and installing fire-rated replacement insulation. This approach maintains system safety, prevents odor and corrosion, and aligns with fire restoration standards and OSHA safety guidelines. Question 13. While examining a fire-damaged HVACR system, Mr. Kim finds that the system's evaporator coil has minor discoloration but no structural deformities. He needs to determine whether chemical cleaning will suffice. Which concept should guide his decision? A. Minor discoloration indicates immediate coil replacement. B. Chemical cleaning can restore coils if the residue type is compatible and fins are intact. C. All fire-exposed coils are compromised and must be replaced. D. Discoloration is purely aesthetic and does not affect system performance. Answer. Correct answer. C. Explanation. Fire-exposed coils may accumulate residues that impair heat transfer, airflow, and odor control. Minor discoloration alone does not always mandate replacement, but chemical cleaning effectiveness depends on residue type, compatibility, and fin integrity. Assuming all discoloration is aesthetic risk system performance issues, replacement is necessary only if residues cannot be safely removed or if integrity is compromised. Decisions must consider residue type, potential corrosion, and restoration best practices to ensure safe, reliable HVAC operation post-fire. Question 14. Considering the evidence is Martinez observes that after fire damage, the thermostat of a large commercial system intermittently fails to respond. Which is the most conceptually sound troubleshooting step? A. Replace the thermostat without further inspection. B. Inspect the wiring and connections for heat damage, test continuity, and verify voltage supply. C. Adjust system settings to bypass thermostat controls. D. Assume intermittent failure is temporary and monitor for 24 hours. Answer. Correct answer. B. Explanation. Fire and heat exposure can compromise wiring, insulation, or connections, leading to intermittent thermostat operation. Replacing without investigation risks repeated failures. Bypassing controls may create safety hazards, while waiting assumes no damage, violating restoration protocols. Correct troubleshooting involves inspecting wiring and connections, testing continuity, and verifying voltage supplied. The system responds correctly and safely. This method aligns with fire restoration best practices, electrical safety standards, and HVAC diagnostic procedures for post-fire systems. Question 15. Given the circumstances Mr. Wilson needs to restore the duct system coated with protein-based soot that has penetrated hard-to-reach areas, which restoration approach is most appropriate? A. High-pressure air and chemical cleaning with access panels opened. B. Simple vacuuming without chemical treatment. C. Sealing all duct openings and running the system to circulate cleaning agents. D. Ignoring inaccessible areas since they are minor. Answer. Correct answer. D. Explanation. Protein-based soot is sticky and requires careful, controlled cleaning. Vacuuming alone is ineffective because it cannot remove embedded residues. Sealing ducts and running the system may circulate residue and odors. Ignoring hard-to-reach areas risks ongoing contamination, odor retention, and system inefficiency. Best practice is accessing all affected sections via panels or specialized tools, applying chemical cleaning methods, and ensuring proper deodorization. This preserves system integrity, prevents future contamination, and aligns with fire restoration HVACR standards. Question 16. As illustrated by recent restorations, HRConquer encounters rooftop unit motor coated with dry smoke residue, but functioning normally. What is the recommended restoration procedure? A. Disassemble motor, chemically clean all parts, and inspect bearings and windings. B. Run the motor at normal load to burn off residue. C. Apply light lubricant and reinstall without cleaning. D. Ignore the residue since dry smoke is non-corrosive. Answer. Correct answer. B. Explanation. Dry smoke is abrasive and may trap odor if left on moving components. Running the motor without cleaning risks embedding residue further, causing wear. Simply lubricating without removing soot leaves contamination. Disassembly and chemical cleaning is the safest approach, allowing inspection of bearings, windings, and housing for hidden damage. This ensures operational reliability, prevents odor, and maintains compliant fire restoration protocols. Proper cleaning preserves motor lifespan and HVAC system performance after fire exposure. Question 17. While analyzing fire damage ductwork, Mr. Singh identifies wet smoke residue and is unsure whether to replace or restore the ducts. Which underlying principle should guide his decision? A. Wet smoke residue can often be restored using low moisture chemical cleaning and encapsulation. B. All wet smoke residues necessitate duct replacement. C. Residue type is irrelevant. Focus on the visual appearance only. D. Duct replacement is required only for flexible ducts. Answer. Correct answer. C. Explanation. Residue type and chemical reactivity are critical in restoration decisions. Wet smoke can often be cleaned and encapsulated if duct materials are compatible, avoiding unnecessary replacement, replacing based solely on residue presence or duct type waste resources. Visual inspection alone is insufficient as odor and corrosion may persist even on visually intact ducts. Proper evaluation involves identifying residue type, selecting compatible cleaning agents, and applying restoration techniques according to fire damage best practices to ensure system integrity, odor mitigation, and long-term performance. Question 18. Through careful analysis of fire-damaged HVAC systems, Lopez notices minor heat discoloration on a blow motor casing with no functional impairment. What is the best course of action? A. Disassemble, clean, inspect bearings and windings before reinstallation. B. Apply insulating paint to mask discoloration. C. Leave the motor as is since minor discoloration does not affect function. D. Replace the motor immediately to prevent future issues. Answer. Correct answer. A. Explanation. Heat discoloration can indicate thermal stress or early corrosion. Ignoring it risks latent failure. Applying paint is cosmetic and does not address internal residues or potential damage. Immediate replacement may be unnecessary and costly if the motor functions properly. Proper restoration involves careful disassembly, cleaning, and inspection of internal components, ensuring long-term reliability. This approach aligned HVAC fire restoration best practices, verifies operational safety, prevents odors, and ensures compliance with safety standards for electrical components. Question 19. With respect to post-fire odor control, Mr. Taylor is tasked with eliminating residual smoke odor in a multi-story building's HVAC system. Which approach is conceptually sound? A. Is sequentially combined duct cleaning, chemical fogging, and ozone treatment as needed. B. Relies solely on changing filters to remove odor. C. Spray air fresheners throughout ducts. D. Run the HVAC system without any treatment to prevent out odor. Answer. Correct answer. C. Explanation. Changing filters or venting alone cannot remove odor molecules embedded in duct surfaces or insulation. Air fresheners mask odors temporarily and do not neutralize them. Comprehensive restoration protocols recommend sequential cleaning, mechanical duct cleaning, chemical fogging to neutralize residue, and ozone treatment for odor elimination. This multi-step approach ensures smoke particulates and volatile compounds are addressed, preventing long-term odor retention, complying with HVAC fire restoration standards, and maintaining indoor air quality across all affected areas. Question 20. During the process of restoring a residential system, Benson finds a refrigerant leak at a fire-damaged compressor. What is the most critical first step to comply with safety and environmental standards? A. Open the system and vent the remaining refrigerant. B. Use EPA-approved recovery equipment to safely remove the refrigerant. C. Apply sealant to the leak while system remains charged. D. Restart the system to circulate refrigerant for testing. Answer. Correct answer. A. Explanation. Venting refrigerant is illegal and environmentally hazardous. Using sealants or restarting the system can worsen leaks or create safety hazards. Proper refrigerant management requires EPA-certified recovery equipment following Section 608 protocols to safely capture and contain refrigerant. This ensures compliance with federal regulations, prevents chemical exposure, and protects the environment. Fire-damaged compressors may have compromised seals, so careful recovery before repair is essential for safe, compliant restoration practices and overall system safety. Question 21. In light of recent developments, Istacata is restoring an HVAC system where protein-based soot has infiltrated the evaporator coil fins. Which approach is most effective for complete cleaning without damaging the coil? A. Use a mild chemical cleaning solution compatible with aluminum and soft brushes. B. Apply high-pressure air to blow residue off. C. Replace the entire coil without attempting cleaning. D. Wipe with a dry cloth and reinstall. Answer. Correct answer. A. Explanation. Protein-based soot is highly adhesive and can penetrate coil fins. High-pressure air risks bending or damaging delicate fins. Dry wiping is ineffective because residue remains embedded, causing odors and efficiency loss. Replacing the coil prematurely increases cost unnecessarily. Using mild, chemically compatible cleaning solutions with soft brushes removes soot while preserving coil integrity, ensures proper heat, reduces odor retention, and aligns with HVACR fire restoration standards and material compatibility guidelines. Question 22. Through the lens of HVACR fire restoration is new and is evaluating a blow-up motor coated in dry smoke residue with intact windings. What should guide her restoration approach? A. Disassemble and chemically clean motor components, inspect bearings and windings. B. Apply lubricant over residue and reinstall. C. Run motor at normal speed to burn off residue. D. Ignore residue since dry smoke is harmless. Answer. Correct answer. B. Explanation. Dry smoke can be abrasive and leave odor if untreated. Ignoring residue risks long-term wear and system inefficiency. Simply running the motor may embed soot further, and applying lubricant without cleaning leaves residue in moving parts. Proper restoration involves disassembly, chemical cleaning, and inspection of internal components. This ensures operational reliability, reduces odor retention, prevents corrosion, follows fire restoration and HVACR motor maintenance standards. Preservation of system integrity is critical in post-fire scenarios. Question 23. Given the circumstances, Mr. Wilson observes that flexible duct sections in a commercial system have wet smoke residues but no structural damage. Which procedure is most consistent with best practices? A. Replace all duct sections regardless of condition. B. Use chemical cleaning with low-pressure methods and ensure proper drying. C. High-pressure air blasting to remove residues. D. Ignore minor wet residues since airflow is still intact. Answer. Correct answer. C. Explanation. Wet smoke residues are sticky and can lead to lingering odors and corrosion. Replacing ducts unnecessarily is wasteful. High-pressure air blasting risks damaging flexible ducts. Ignoring residues allows odor retention and potential contamination. Correct restoration involves low-pressure chemical cleaning compatible with duct materials, followed by careful drying to prevent moisture damage and microbial growth. This preserves duct integrity, restores indoor air quality, and complies with fire restoration and HVACR safety standards. Question 24. From a practical standpoint, Parker must assess whether a rooftop unit's refrigerant lines exposed to heat and smoke are safe for continued operation. Which concept should guide her decision? A. Minor heat discoloration does not compromise refrigerant line integrity. B. All fire-exposed refrigerant lines require immediate replacement. C. Inspect lines for corrosion, leaks, and material degradation before determining repair or replacement. D. Apply sealant to discolored lines and resume operation. Answer. Correct answer. D. Explanation. Refrigerant lines exposed to heat may develop micro cracks, weaken joints, or corrosion. Assuming minor discoloration is harmless, risks leaks and system failure. Blanket replacement may be unnecessary. Using sealants without inspection can trap contaminants and worsen issues. Best practices dictate inspecting all exposed lines for leaks, corrosion, and mechanical integrity before deciding on replacement. This approach ensures safe operation, maintains system efficiency, and follows HVACR fire restoration and EPA refrigerant handling standards. Question 25. While examining an air handler after a fire, Mr. Lee finds the fan blades coated with sticky wet smoke residues. What is the most effective restoration technique? A. Disassemble fan assembly, chemically clean blades, and inspect motor and bearings. B. Wipe blades with a dry cloth and run the system. C. Apply a protective coating over residue. D. Replace the fan blades without attempting cleaning. Answer. Correct answer. A. Explanation. Wet smoke residue is highly adhesive, can retain odors, and affect balance and airflow. Dry wiping is ineffective, and protective coatings may trap residues, creating corrosion or odor issues. Replacement without cleaning is costly and often unnecessary. Best practices involve careful disassembly, chemical cleaning compatible with metal and coatings, and inspection of motor and bearings to ensure safe, efficient operation. This restores system performance, prevents odor retention, and complies with fire restoration HVACR standards. Question 26. Demonstrated by fire restoration protocols is Rodriguez needs to eliminate smoke odors from ductwork that cleaning alone could not remove. Which technique is most reliable? A. Ozone treatment or thermal fogging. B. Increasing fan speed to circulate air. C. Masking with scented chemicals. D. Cover ducts with plastic sheeting and run the system. Answer. Correct answer. C. Explanation. Air circulation alone does not neutralize smoke, residues, or embedded odors. Scented chemicals only mask odors temporarily and do not address the source. Covering duct traps residues and does not mitigate odor. Ozone treatment or thermal fogging penetrates duct surfaces and reacts chemically with odor-causing compounds, neutralizing them effectively. These advanced methods align with professional fire restoration practices, ensuring odor elimination while preserving duct materials and maintaining HVAC system performance. Proper ventilation post-treatment ensures safety and air quality. Question 27. Through careful analysis, Mr. Thompson finds electrical wiring in a fire-damaged HVAC system partially melted at junction boxes. What is the most appropriate course of action? A. Replace all affected wiring and test circuits before energizing the system. B. Wrap melted insulation with electrical tape and operate normally. C. Ignore minor melting since the system still functions. D. Only replace wiring near the thermostat. Answer. Correct answer. A. Explanation. Partial melting indicates compromised insulation and potential short circuits. Simply wrapping with tape or ignoring it risks electrical fires or shock hazards. Replacing only near the thermostat leaves other compromised areas at risk. Best practice involves replacing all affected wiring and testing circuits to ensure integrity, operational safety, and compliance with OSHA and NFPA guidelines. Proper document of repairs and testing ensures adherence to fire restoration protocols and maintains system reliability. Question 20. Considering the evidence is Johnson needs to determine if the evaporator coil in a small office system can be chemically cleaned after light protein-based set exposure, which concept should guide her? A. Inspect coil for fin damage and chemical compatibility before cleaning. B. Replace coil immediately due to any fire exposure. C. Use high-pressure air without chemical treatment. D. Wipe lightly with a dry cloth and reinstall. Answer. Correct answer. D. Explanation. Protein-based sedatives strongly to coil surfaces and can cause odor and efficiency issues. High-pressure air risks bending fins. Replacing coils unnecessarily is costly. Dry wiping alone is insufficient for embedded residues. Proper restoration requires inspecting fin integrity using compatible chemical cleaners and applying low-pressure cleaning methods. This ensures system efficiency, odor mitigation, and material safety. Decisions should be guided by residue type, coil condition, and fire restoration best practices. Question 29. In terms of post-fire system verification, Mr. Edwards has completed duct cleaning, odor mitigation, and motor restoration. What is the final step before declaring the system operational? A. Perform full system startup, measure airflow, voltage, and temperature outputs. B. Replace all filters and restart the system. C. Document restoration and schedule inspection later. D. Assume restoration was successful and resume normal operation. Answer. Correct answer. A. Explanation. System functionality cannot be assumed after restoration. Replacing filters alone does not confirm operational safety or performance. Scheduling future inspection delays detection of potential failures. Proper verification involves full startup, measuring airflow, electrical load, and temperature outputs to ensure components function safely and efficiently. This aligns with HVACR fire restoration standards, ensures system reliability, prevents odor or performance issues, and demonstrates due diligence and compliance with safety protocols. Question 30. During restoration, Bailey finds minor corrosion on copper tubing after a fire with light smoke residues. Which restoration approach best balances safety, cost, and system longevity? A. Chemically clean copper, inspect for leaks, and pressure test before reuse. B. Replace all copper tubing immediately. C. Apply sealant over corrosion without cleaning. D. Ignore minor corrosion since tubing appears intact. Answer. Correct answer. B. Explanation. Minor corrosion may compromise long-term system integrity if not addressed. Ignoring corrosion risks leaks and system failure. Applying sealants without cleaning leaves corrosive residues in place. Immediate replacement may seem costly but ensures safety, prevents future leaks, and maintains HVACR system performance. Proper restoration requires evaluating material condition, residue type, and applying cleaning or replacement in accordance with fire restoration best practices, material compatibility, and system longevity principles.